What type of triangle is PQR? Is it isosceles, scalene, obtuse, angled, or equilateral? Well, how do you identify an isosceles triangle? An isosceles triangle has two equal sides. And right here, we have two sides, 11 centimeters here and 11 centimeters there. So we are sure that the triangle is isosceles. We could run into a little bit of problems if we were just looking at two sides to say that it is isosceles, because we have another side here. If this side were equal to 11 centimeters also, then that would make the triangle equilateral. But we only have two equal sides, so we are sure that the triangle is isosceles. So option A is correct. An isosceles triangle has only two equal sides. An isosceles triangle has only two equal angles also. So option A is correct. What about option B, scalene? How do we identify a scalene triangle? A scalene triangle has three sides, all different in length. Because of this, no two angles are equal. Option C, an obtuse angle triangle. That is what we have for option C. How do we know an obtuse angle? Well, from the previous section, we looked at an obtuse angle, and we realized that an obtuse angle is greater than 90 degrees but less than 180 degrees. We do not have any angle here that is greater than 90 degrees. So we are sure that it is not obtuse angle. What about equilateral? An equilateral triangle has all sides equal. This means that all of the angles are equal also. If all of the angles of a triangle are equal, then each one has to be 60 degrees. So we are sure that isosceles triangle, option A, is correct. An angle is 200 degrees. What type of angle is it? Is it acute? Is it reflex? Obtuse or right? Well, we took a look at a diagram recently, and I'm going to put the recent diagram on the board also. So, how do we know an acute angle? An acute angle is given relative to a right angle. A right angle is 90 degrees. An acute angle is less than a right angle. So, option A, we are taking a look at option A, of course, that says acute angle. An acute angle is between 0 and 90 degrees. So we are sure that's not the correct answer. So let us take a look now at the diagram that we designed from a few slides ago, in order that we might be able to have some order to determine the type of angle that we have there, 200 degrees. So there is your right angle. Your right angle starts at 0 and it increases size until it reaches 90 degrees. So 90 degrees, that represents your right angle. A right angle is marked in a special way like that by using also lines that are 90 degrees to each other. This region is therefore your acute region, because in this region we have angles between 0 and 90 degrees. Option A cannot be right because an acute angle is less than 90 degrees. But the angle that we have there is 200 degrees. So that angle that we have here, 200 degrees, cannot possibly be an acute angle because it is greater than 90 degrees. Angles on a straight line is equal to 180 degrees. Any angle between 90 degrees and 180 degrees is an obtuse angle. So this is our obtuse region, the region between 90 degrees and 180 degrees. Do not forget that our angle that we start measuring is from 0 degrees, which is this line. So now we have this final line that we have here, the angle that we have the way around, beginning at 0, the angle that goes all the way around is 180 degrees, causes a straight line to exist in the diagram. So we usually say angles on a straight line are equal to 180 degrees. Now, is the angle that we have obtuse? No, it is not an obtuse angle. Why is it that it's not an obtuse angle? It is not an obtuse angle because obtuse angles are between 90 and 180 degrees. The angle that we have right there is 200 degrees. So this angle is not within the obtuse region, so it is not obtuse. Now we have another region, which is the region specified by angles that are greater than 180 degrees and less than 360 degrees. So that region is called the reflex region. 200 degrees is greater than 180 degrees and less than 360 degrees. It is therefore a reflex angle. The correct answer is option B. How many edges does a triangular pyramid have? You're trying to trick me by pointing on all of the answers, Jerry. So what I'll do, I'll go through the instruction so that we can both solve this problem. Now we have this statement that says, if a solid figure is constructed by using only straight lines, then the number of edges of the figure is equal to the number of lines used to construct it. Let us construct a triangular pyramid and count the number of lines that we use. So we are going to construct a triangular pyramid and we are going to count the number of lines, because the number of lines that we use to construct the pyramid is going to be equal to the number of edges of the pyramid. So let's go. 1, 2, 3, 4, 5, 6. We used 6 lines in constructing the pyramid. Therefore, the number of edges that the pyramid has is 6. 6 lines were used. Therefore, the number of edges is equal to 6. This option is option C. A triangular pyramid has a triangular base. Line number 3 is a dotted line because, according to the position of the solid, line number 3 should not be visible. So if this pyramid existed and is sitting on a table, we would not be able to see this line which would be at the back of it. Therefore, it is dotted. It is going to be there, but we will not be able to see it. So we are going to cause that to be in the diagram by using a dotted line. Which line is a chord? Well, let us see if we can determine what a chord is first. A chord is any line that goes from one point on the circumference of a circle to another point on the circumference. What is the answer? It must go from one point on the circumference to another point on the circumference. What is that line? That is one. Is there any other that goes from the circumference to the circumference? Right. Good. Now, the chord that were just pointed out by Jerry are AC and AB. However, we are going to use, or we're going to look at the options here to see which one of the chords that are given here are in the option. Which chord is in the option? Now, let us look at the chords that goes from the circumference to the circumference. AC is one, AB is another, CD is another. Let us look at AC. AC is there, correct. So the answer is AC, which is option A. What about OA? OA goes from the center to the circumference, so this one is not right. The chord needs to go from one point on the circumference to another point on the circumference. So we know that OA is out. What about OB? OB goes from the center to the circumference. That's not right. What about AD, OD? OD goes from the center to the circumference. So that is not a chord either. Good. No, right? That's not a chord. So the answer is AC. The only line presented in the options that does this is AC. Option A is therefore the correct answer. Good. Notice that in the diagram we have other lines that are chords, but we do not have them in the options. So what is the length of CD? That is CD. All right. It is given in terms of the others. So what? A half of OA? Is it a half of OA or 2 times OA? Let's see. Now the line that we're looking at is CD, from C to D. CD is a chord that passes through the center of the circle. That chord is called a diameter. It divides the circle into 2 equal parts. AB is also a diameter. So those 2 lines are diameters. All right. Okay. You'll get the opportunity to answer the question in a short while. Any line that goes from the center of the circle to the circumference is called a radius. The plural of radius is radii. OA, OB, OC, and OD are all radii. So there you have the first one. OA is one radius, OC is another, OB is another, and OD is another radius. We may say that the diameter is twice the radius, or we may say that the radius is half of the diameter. So now, Jerry, which one is the correct answer? So look at this one. Is CD a quarter time OA? Is CD a quarter of OA? What do we have down here? There is no quarter, there is no 4 nor quarter in the relationship between the radius and the diameter. Option A is out, so we cannot use option A at all because there is no 4 times or a quarter of in the relationship between radius and diameter. CD is a diameter and OA is a radius. Now the diameter is always twice the radius. The diameter is greater than the radius and therefore cannot be half of it. So we are looking at B here. Is CD half of OA? CD cannot be a half of OA because OA is a radius and is smaller than the diameter, which is CD. Therefore, CD cannot be a half of something that is smaller than it. So we know that this one is out. What about 2 times OB? The diameter is greater than the radius and therefore cannot be half of it. Option B. Okay, so CD is equal to 2 times OB. Right, that is correct. Right, so that is the correct answer. So CD is twice OB because OB is a radius and CD is a diameter. Right. So the correct answer is therefore option C. Why can't this be right? 2 times AB. AB is a diameter and CD is a diameter. So CD, the diameters of the same circle cannot be twice. One cannot be twice the other. Both of them are equal because they are diameters of the same circle. So we are sure that D is not right. So CD is twice OB. CD is the diameter and OB is a radius and the diameter is twice the radius. Good. Which shape represents an acute angle? Let us rehearse the type of angles from a previous slide. So here's your slide. Let us look at the types of angles. Right, so that is a right angle. 90 degrees is a right angle. So the acute region is a region between 0 and 90, between 0 and a right angle. So the angle that we are looking for is required to be less than 90 degrees in order to be an acute angle. Of course, let us take a look at the obtuse region also. So between 90 and 180 degrees, we have our obtuse region. And the reflex region is between 180 degrees and 360. Any angle in the acute region is between 0 degree and 90 degrees. Which angle looks smaller than the right angle shown in the diagram? So which one of these looks smaller than the right angle? Of course, we have another right angle here. This is a right angle. You know that right angles are marked in a special way like this. So this is a right angle. An acute angle is smaller than this one. So which angle is smaller than C? Which is smaller than a right angle? How can you identify them? Well, at first glance, these two angles look smaller than the right angle. So we are looking at B and D. They look smaller than the right angle. So angles B and D look smaller. Notice that the curve with the arrow in angle D is on the outside, indicating a reflex angle instead of an acute one. So in D, notice the angle is all the way around here because the arrows are on the arc that marks the angle. They are on, this is on the outside. So the angle is the one all the way around here. So this angle is not less than 90 degrees. Therefore, the one that we opt for is B. So the angle is B. The answer is therefore option B. Right, so that is your answer. Don't forget that although this angle looks acute, it's not acute because of the region outside here. What is the size of the angle W in the triangle? What is the size of the angle W? What tips can we use in finding the angle W? Let's go. The two marks on lines UW and VW show that they are equal in length. So we have two marks right there. Those two marks show that the two lines UW and VW are equal in length. Because they are equal in length, the triangle is therefore isosceles. And if the triangle is isosceles, what do you know? The two angles at the vertices where the two lines do not meet are also equal. So the two angles at the vertices where the two lines do not meet are also equal. So the two lines meet at this vertex W. Therefore, the two angles at the vertices where the lines do not meet, the lines do not meet here and here. So these two vertices, the angles at these two vertices are equal. So the lines meet at the vertex W. The other two angles are equal. So that one is also at 65 degrees. Okay. The two vertices that we have where the lines do not meet are these two. Vertices are points where, if you have a plane figure like what we have right here, the vertices are the points where the two lines meet. So we have vertex V. As a matter of fact, a single one is a vertex, and we have two vertices. So vertex V is where this line meets this line. So that's a vertex. And also, U is at a vertex where this line meets this line. So the lines meet at the vertex W. The other two angles are equal, and we have that right there. They are at 65 degrees each. The angles in a triangle add to give 180 degrees. Two of the angles are already known. They measure 65 degrees each. So we have two angles already. Out of the 180 degrees, we know that two other angles are 65 degrees. So let us put those two angles together. We may say 2 times 65, right. You're right. Jerry Lewis has figured out the answer already. And he's saying that the answer is 50 degrees. That means he's learning. So if you cannot learn, wherever you are in Jamaica or the Caribbean, you are in serious trouble. Jerry Lewis is having wonderful fun figuring these things out even before I am finished with these problems. So we have the two angles. We may say 2 times 65 degrees, which is equal to 130 degrees, or we may say 65 degrees plus 65 degrees, which is 130 degrees, because those two angles are equal to 65 degrees each. The other angle is the rest of 180 degrees. We therefore need to subtract 130 degrees from 180 degrees in order to find the angle W. So let us do that. So W is equal to 180 degrees minus 130 degrees, and that is equal to 50 degrees, and that is option C. This represents option C, of course, which represents a vertical line. What's that? That diagram shows the cardinal points on a compass. Right. And all students at the GSAT level should know these. If not, then there's a wonderful diagram showing you the north, the east, the south, and the west. Any line that goes from north to south as shown by the cardinal direction is vertical, and so is any line that goes in that same direction. So if you put a line right there that goes from north to south, then that line is considered to be vertical. Any line that goes in that same direction is also vertical. Good. Notice that the vertical line matches perfectly with line B. It is therefore the correct answer. Right, Jerry Lewis is rejoicing. He is really impressed with what is going on so far. So we can see that that vertical line matches perfectly with line B. So that line in option B is vertical. So your correct answer is B. To identify a horizontal line, consider the line that marks where the sky and the sea appears to meet. The line is called the horizon and is similar to the word horizontal. So if you wanted to take a tip, you may use a linguistic approach to it. Horizon, horizontal. So you will not forget that the horizontal line is the one that goes in the same direction as the horizon. So line D is an example of a horizontal line. Line D is horizontal because it is in the same direction as the horizon. Right. Lines A and C are neither vertical nor horizontal. The descriptive word for such lines is oblique. So those lines are described as being oblique because they are neither vertical nor horizontal. Which triangles are congruent? What do you know about congruency, Jerry? They are the same. Okay. Well, let's begin with that they are the same. The word congruent is used to describe objects that are exactly the same. So they are the same in every respect. All right? So what are you going to say when you see the animations for this one, Jerry? All right, you start to rejoice already. Wait until you see it. Based on the meaning of the word, students should not find difficulty identifying A and D as congruent. The answer is therefore option D. Right, so the answer is option D because A, if you look in the diagram, the ones that seem to be exactly the same are triangles A and D. Now, in order to show that they are really congruent, I've taken a triangle from outer space that is exactly the same size as A. And what do you think I'll do next? Make a guess. All right, look. It goes exactly over triangle D. So we are sure that triangles A and D are exactly the same. Good. So they are congruent. And we were right in the first place. If two triangles exist in such a way that there is a one-to-one correspondence between sides, then they are congruent. A one-to-one correspondence between the sides of a triangle causes a one-to-one correspondence to exist among the angles. So let me repeat that. If there's a one-to-one correspondence between the sides of triangles, then there's a one-to-one correspondence between the angles. However, the reverse is not true. If we have a one-to-one correspondence with the angles, we do not necessarily have one-to-one correspondence with the sides, and we'll show that in a minute. Not all triangles that have one-to-one correspondence among angles will have one-to-one correspondence among sides. Therefore, if two triangles have equal angles, they are not necessarily congruent. So, triangles that have all sides equal are congruent. But if there's a triangle with all the angles equal, if we have two triangles with all the corresponding angles equal, those two triangles are not necessarily congruent. So, we are going to use a geometric device in order to cause two triangles to have the same angles. So this angle here is equal to the one over here. How do we do that? We use this device that causes one to be an enlargement of the other. That means to get one triangle, we just enlarge the other. So we have A, B, C, and then we have a triangle A prime, B prime, C prime. Now, the sides are given right there as 3 centimeters, 4 centimeters, and 6 centimeters. And let's see what the other one is. The sides are 6 centimeters, 12 centimeters, and 8 centimeters. So we can see that this is 4, 8. This is 3, 6. This is 6, 12. So we know that this triangle, each side is twice the side of the corresponding triangle. Therefore, we are sure that corresponding sides are not equal. But because one is an enlargement of the other, we are sure that the corresponding angles are equal. So in the diagram above, angle A is equal to angle A prime, angle B is equal to angle B prime, and angle C is equal to angle C prime. The triangles are not congruent because the lengths of the corresponding sides are not the same. Although the angles are equal, the triangles are not congruent. Why? Because the lengths of the sides are not the same. Right, so it is more the length that determines congruency than anything else. Right. So let us take a triangle and rotate it. So we're going to look at that one. There's your triangle. Let's rotate that. Good. We are sure that the resulting triangle is congruent to the first. How can we be sure? Because it is only a rotation of the first triangle. So because one is just a rotation of the other, we are sure that they are congruent because this triangle is the same as this one. So they are congruent. When one shape is only a rotation of another, we say that they are different in orientation. Also, objects can be congruent even if they are of different orientation. So if they are different in orientation, they still can be congruent. So as a matter of fact, this triangle is congruent to this one. Which of the regular polygons has only 3 lines of symmetry? What is a line of symmetry? A line of symmetry is one that causes the portion of an object on either side to be mirror images of each other. So if you put a line of symmetry on an object, the part on one side of the line is a mirror image of the other part that is on the opposite side of the line. The easiest way of identifying a line of symmetry is to see if it divides the object into 2 equal parts. Let us look at the number of lines of symmetry of each of the objects. So we're going to take the first one and look at the lines, the number of lines of symmetry. That's 1, 2, 3. So that triangle has 3 lines of symmetry. What about this one? How many this will have? One, 2, 3. Right, so it has to have another one, because the other diagonal has to be 1 also. Okay, good. So 1, 2, 3, 4. So Jerry Lewis did include this one, but did not include the other diagonal. That was line number 2. So let us begin again. 1, 2, 3, 4. What about this one? How many lines of symmetry do you imagine? How many lines of symmetry do you imagine? All right, 1, 2, 3, 4, 5, 6. Right, so that will have 6 lines of symmetry. Now, I will not bother to count the number of lines of symmetry that the last shape will have. Why? So Jerry Lewis saying that we do not have to count the other one because this one is 6. So this one is going to be equal to 6 or more. So we don't really have to count it. And the problem says which of the regular polygon has only 3 lines of symmetry. So because it is going to be 6 or more, we don't need to count it. Because it's going to always be greater than 3 anyway. But let's see what this statement is saying to us. There is no need to count the number of lines of symmetry of an octagon. Not only because it is sure to be more than 3, but because for all of the other shapes, the number of lines of symmetry is equal to the number of sides of the figure. The triangle is the only figure with only 3 lines of symmetry. Option A is correct. Notice that this is a 4-sided figure, and the number of lines of symmetry is 4. This is a 6-sided figure, and the number of... Right. So how many lines of symmetry the next one will have? Jerry Lewis is counting the number of sides. 8. Right. So 8 sides, so it should have 8 lines of symmetry. So that is correct. A is the correct answer. Only the triangle has only 3 lines of symmetry. Which shape is not a quadrilateral? Which shape is not a quadrilateral? What is a quadrilateral? Quad. Quadruped, an animal with 4 legs. Right, good. So Jerry Lewis has already identified C to be the correct answer. But we are looking at quadrilateral. Which one is not a quadrilateral? How do we know quadrilaterals? So this is saying to the students, come on, even Jerry Lewis can tell which of the shapes is not a quadrilateral. Jerry Lewis did that a long time ago. So Jerry Lewis now is gone international. Right. So even Jerry Lewis can tell. A quadrilateral has how many sides? First, we need to ensure that we know what is a quadrilateral. A quadrilateral is a 4-sided figure. Now, which one does not have 4 sides? Let's see. Count the number of sides in each figure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. So that is our culprit. We have found our culprit, option C. Right. The other one is also a 4-sided figure, so we do not need to count that one. In the triangle, which is a right triangle, in a right angle triangle PQR, angle R is equal to 50 degrees. What is the size of angle Q? All right. All the angles of a triangle are to give 180 degrees. In a right angle triangle, the size of the right angle is 90 degrees. So let us take the size of the right angle from 180 degrees. So we know that in this triangle, P is 90 degrees because it is a right angle. So if we take out this right angle, what is going to happen? We are going to have 90. So 180 minus 90 is equal to 90 degrees. So if we take out this angle, the angle that is left is 90 degrees. And that 90 degrees must be shared between R and Q. That's very good, Jerry. If after taking out 90 degrees, the result is 90 degrees, this means that the two remaining angles should add to give 90 degrees. So what are the two remaining angles? R and Q. Good. Oh, you start to show me that R is equal to 50 already. All right. One of the angles is Q. The one whose size we do not know. So the angle is Q. One is Q, and that is the one whose size we do not know. The other one is R, whose size is 50 degrees. They both should add to give 90 degrees. So which one we do not know? Q. How can we tell? Because it says, what is the size of angle Q? Couldn't ask what is the size of angle Q if we know the size of angle Q. Right. So Q and R require to add to give 90 degrees. So Q plus 50 degrees is equal to 90 degrees. All right, see if you can figure out what is Q. How do we determine Q from here? What do we do with that 50 degrees? Oh, yes. So it is added on the left-hand side. So we are going to take it to the right-hand side. We are going to minus. Very nice. Well, 50 degrees is added on the left-hand side. We therefore minus 50 degrees from the right-hand side. Okay. Right. Good. So we do the opposite on the opposite side. So we have an addition. The opposite of addition is subtraction. So we subtract from the other side. Good. So make sure you all students, make sure that you understand every single thing, because Jerry Lewis is going to be very disappointed if after seeing these slides and videos you are in any way lacking in mathematics. So what is 90 minus 50? 40 degrees. And that represents option D. Good. All right. Okay. So the answer is option D. Now, Mr. Lyons bought 10 pounds of meat. The pie chart shows the different kinds of meat bought. What is the size of the angle in the region represented by pork? That is our question. Now, we need to know for pork, but let's see what the animation says, because it might help me to be able to work out this problem. When an angle is marked in this fashion, what kind of angle is it? It is a right angle, and a right angle is equal to 90 degrees. So where is 90 degrees? That region. That region outlined in blue, this is 90 degrees. So the region specified includes beef and pork, and the associated angle is 90 degrees. So beef and pork together represents 90 degrees. This means that the angle for beef, which is 60 degrees, and the angle for pork that we are trying to find both add to give 90 degrees. So add them. Add pork plus beef is equal to 90 degrees. Do we know the size of any angle in this equation here? Pork plus beef. What do we know? All right, good. So beef, the angle associated with beef is 60 degrees. So instead of having beef here, we could put 60 degrees. So remember that beef is equal to 60 degrees. Replace the beef with 60 degrees. And then we have pork plus 60 degrees is equal to 90 degrees. Good. And by the time I snap my finger, Jerry Lewis will have the answer, because he's saying that we are going to take the 60 degrees to the right-hand side. It is added on the left-hand side, so we are going to subtract that from the right-hand side. So we have then 60 degrees is added on the left-hand side. We therefore subtract 60 degrees from the right-hand side. So pork is equal to 90 degrees minus 60 degrees. And what does that turn out to be? 30 degrees, right, and that is option A, right. So answer is option A. Which solid does this shape represent? Yeah. This is going to be a handful for me. Is it a cylinder? Well, my instruction that I have right here says the figure is a cone. Gives the answer away immediately. Or it may be called a circular pyramid. It belongs to the family of solids called pyramids. The answer is therefore option B. So soon, with this acre of space that we have down there, let's see what we will... Oh, we have some more information. Pyramids are considered to have a base and an apex. So a pyramid has a base and an apex. But what is an apex? An apex is the top or highest part of something, especially one forming a point. So the apex is the top, especially when it forms a point. But we have the point down here. So how are we calling it apex? With the point down here. Anyway, the cone is a pyramid, and it is most often seen with the circle at the base, except when we are eating ice cream, of course. So that is how a cone is generally represented, with the circle at the base and the point at the top, which is called an apex. So that is your cone. Other pyramids are also named by the shape of their bases. The one with a triangular base is called a triangular pyramid. It is also called a tetrahedron because it has 4 faces and 4 vertices. So there you have a triangular pyramid. That is a triangular pyramid. And it is also called a tetrahedron because if you can count the number of sides, you will get 4. And if you can count the number of vertices, you will get 4. The prefix tetra means 4. A rectangular pyramid has a rectangular base. So let us see if we can have one good. So that is your rectangular pyramid. It has a rectangular base. A cylinder belongs to a family of shapes called prisms. Prisms are identified because of what is called a uniform cross-section. This means that a prism can be cut up into slices, all of which are the same size. One good example of a prism is a bread. Now, a prism has what is called a uniform cross-section, and all that it means is that there's a way that you can cut it up into slices of equal size. So, prisms are also given names according to the shape of their cross-section. The cylinder is therefore a circular prism. This diagram will show the cylinder along with rectangular and triangular prisms. So we're going to have a diagram that shows the cylinder, which is of course a circular prism, and it's going to show a rectangular prism, which is also called a cuboid. And now we have that triangular prism. Now, Jerry Lewis, can you tell us why this line is dotted? Or why are these lines dotted? Oh, right. So they are drawn with dotted line because when we put this solid on a flat surface, we will not be able to see them. But they are there, but we will not be able to see them. That is very good, Jerry. If R is equal to 209, what is 4R? What does 4R mean? We first need to know the meaning of 4R. Right. So in algebra, whenever a letter follows a number in that manner, like 4R, it means that the number is multiplied by the letter. Therefore, 4R means 4 multiplied by R. The value of R is given as 209. Therefore, we need to multiply 4 by 209. That's right? Is that enough? 4 multiplied by 209 is equal to 836, and that is option B. However, we are going to work out the multiplication process that even Jerry will be able to follow. 4. Good. So what do we say now? We say 4 multiplied by 9 is equal to 36. Do we write down 36, Jerry? Do we write down the entire 36? What do we do? Okay, so we are going to write this 6 down. See there? Write down 6 and carry 3 to the 10th column. So we are going to write down the 6 and we are going to carry the 3. Good. Then what do we say? 4 times 0. I don't want to hear that 4 times 0. Is 0. Right. Okay, good. So it says 4 multiplied by 0 is 0. Because if you say 0 divided by 4, it is 0. Okay, good. So 4 multiplied by 0 is 0. And then what do we do with the 3? Right, so we add 3. So 4 multiplied by 0 is equal to 0. And 0 plus 3 is equal to 3. So we're going to have 3 right there. And then 4 multiplied by 2 is 8. And that's all there is to it. The answer is 836, and this represents option A. Good. Be aware that in algebra, AB means A multiplied by B also. So if you have AB, it means A multiplied by B. If you have 4R, it means 4 multiplied by R. Now Jerry is going to have a field day. He's going to be in a very, very good mood now. Let us write down the equation. It says here, if 684 plus n is equal to 749, what is n? Write the equation. What do we do now? Right, so we're going to take the 684 to the other side, which is to the right-hand side, and what do we do with it? Add, multiply, we subtract. Good, we are going to subtract. Why do we subtract? Because they are added together on the left-hand side, so we're going to subtract on the right-hand side. The number 684 and n are added on the left-hand side. We therefore subtract 684 from the right-hand side. So let us do that. So n is equal to 749 minus 684. So n is equal to 65. Is that all? We are going to work it out. So what do we say now? 9 minus 4 is equal to 5. So that's what this is. 9 minus 4 is equal to 5. And what do we say now? 8 minus 4 is equal to 4? Okay, no, we cannot say that. So what do we say then? Okay, right. You stay there. Jerry telling me to borrow. Well, in this case, we do not borrow because everything you borrow, you have to give it back tomorrow. Right? Right. So we are going to, the term that is used now in GSAT is that we rename. So we are going to, 8 cannot be subtracted from 4, so we go to the hundreds column and rename. So we are going to rename the 7 to 6, and what will happen? The 1 will go right there. So we'll have what now? 8 from 14, or 14 minus 8, and that will give us 6. So 8 from 14 is equal to 6, so we put the 6 right there. And what do we do next? 6 minus 6 is equal to 0, and there is no need to write that 0. So the answer is 65, and that represents option D. Lovely. Now, what is the value of R if 3 to the power of 2 is equal to R? So we need to know what R will be if 3 to the power of 2 or 3 squared is equal to R. But let me just clarify what this means in terms of raising numbers to powers and all of those things. So I need to clarify that. That is, so that is your base right there. And the number that goes up to the top is called what? Exponent. Jerry Lewis, you're using big word on me. Exponent. All right. It is called the index. Other names for index? What are the other names? Exponent. I'm wondering why Jerry Lewis used that word first. Exponent. And now you're using power. I imagine that you'd say power first. But you use any one you want. So what about this one? Oh. First you're hearing that? What about logarithms? Right. So when you go to high school, you'll be working with a lot of logarithms. But we're just shortening it and we are calling it log. Right. So log and the power are the same thing. So other names for index are exponent, power, and log. And the number that we have here is the base. The power tells us the number of times that a base is multiplied by itself. Therefore, if we have a to the power of 5, it tells us that it is multiplied by itself 5 times. So we have 1, 2, 3, 4, 5 of them being multiplied together. So a to the power of 5 tells us that they are 5/8 multiplied together. What about b squared? B to the power of 3 is cubed. Right. Okay, Jerry Lewis is not allowing me to make a single mistake here today. So b to the power of 3 is equal to b times b times b, which is we have 3 b's multiplying together. So b to the power of 3 tells us that there are 3 b's multiplying together. So 3 to the power of 2 is the one that we have there. Tells us that there are 2 3's multiplied together. Like that. So what is the answer? The answer is option C. There we have it. So which of those number statements is true? So which one is true? Is this one true? All right, let's take them one by one. The sign, which is this one, means not equal to. So we take our statement and what do? We work out the expressions on both sides of the sign. So we're going to work out the expression on the left-hand side and on the right-hand side. The left-hand side says 2 multiplied by 2. What is that? 4. And the right-hand side says 2 plus 2, which is that? 4. So let us write that 4 is not equal to 4. So when we work out the expressions on both sides, the statement is saying 4 is not equal to 4. Is that true? 4 is not equal to 4. Is that true? Okay, that is not true. So we know that A is not our correct answer. It says 4 is not equal to 4. This statement is not true. What about that one? 2x. What about this sign? What is this sign? This sign is the greater than sign. So work out the expression on both sides of the sign. So we're going to work out the expressions on both sides of the sign. So what is 2 times 8? 16. 2 8s, 16. And what is 4 3s? 12. So let us say 16 is greater than 12. Is that true? 16 is greater than 12? Right. 16 is greater than 12. So the statement can be read, 16 is greater than 12. This is true and option B is correct. There you go. What about that one? We just finished some work on indices, so we should not have any problem working this one out. The power tells us the power tells us that there are 2 3's multiplying together and 3 2's multiplying together. So if we multiply 3 by 3, so we have 2 of them. 3 by 3 is 9. Good. And we have 2 to the power of 3, so we have 3 of them. So we have 2 times 2 times 2 is 8. Good. Jerry Lewis Sharp today is working out these things. He's probably saying that we are at the end of, or close to the end of this section, and he's hurrying to go and play football, or he's going to watch Asafa Powell and Usain Bolt. So we have 3 times 3 is equal to 2 times 2 times 2, and let us see, 3 times 3 is equal to 9, and the right-hand side is equal to 8. They are not equal. The statement is not true. And the final statement that we have, the sign that we have right here, which is the same one that we have there, is the less than sign, right? I don't want to hear you saying lesser than. Is a less than sign. So we are saying 15 minus 3 is less than 6 plus 5. What is 15 minus 3? 8. 8? Oh, 12. Good. 12. And what is 6 plus 5? 11. Right, so we are going to work out the expression on both sides, and we get 12 is less than 11. Okay, no, not at all. So that statement is not true. So we are sure that our answer is option, what did we say that it was? B. So the statement is therefore saying that 12 is less than 11. This is a false statement. A child had 20 marbles. He got some more. He then gave away 10, leaving him with 15. Which mathematical statement represents this information? Can you just look at the entire thing and tell? All right, don't try to do that. Let me show you a strategy that we can use, Jerry. Yes, we take them we divide the statement into different sections and we take them one by one. And of course, we are going to be using colored rectangles to highlight the section that we are on. A child has 20 marbles. So we put down the 20. The first statement says that the child has 20 marbles. So let us write down the 20 marbles. That's good. The next part of the statement said what? He got some more. Now we do not know how many marbles more he got. But what we are sure of, when we look inside this problem, we see n, 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 n. Therefore, the number of marbles that he got, we do not know. But because n is in the answer, we are going to say that he got n more. So if you got n more marbles, what do you do with the n? More, yes, more, that means you add. Good. So the next statement said that he got some more. The unknown that is used in the answering is n. So let us use n also. He got some more. He has an additional n marbles. So add n to the 20. That's good. Pick another part of the statement. He then gave away 10. All right, so if he gave away 10, he's going to have less. So he's going to be subtracting 10. So let us see what the statement says. If he then gave away 10, then 10 marbles are gone. So we take away 10 from the amount that is there already. But what's the amount that is there already? 20 plus n. So we're going to take away 10 from that. So that's what we are at now. Leaving him with 15. So what do we say? The number of marbles that he had after doing all of his shuffling is 15. This means that the algebraic statement is equal to 15. Right? So which one is the same as that one? The correct statement is option A, because it is the exact same thing that we have right there. Option A is correct. Mary is 23 years old. What will be her age in n years from now? So what will be her age n years from now? All right, let's see how the computer helps us. If Mary is 23 years old, then every year from now, she will increase her age by 1 year. So 1 year from now, she will have another 1 more year to her age, right? Right. So she will increase her age by 1 year. 1 year will be added to her age each time. This means that n years from now, n will be added to her present age. So what is her present age? How do you know that it's 23? Right, it is in the question that says that Mary is 23. So we're going to add n to that. So it's going to be what? The answer is option C, 23 plus n. And we have come to the end of this section. Have some fun. If you wish, you may review or you may want to go on to the next section.